Welcome to qnawire.
Welcome to problem number 10.56. This is chapter 10, Dynamics of Rotational Motion. So we are given that there is a sphere and the diameter of this sphere is 50 centimeter. It has mass equals to 8.4 kg and there are four small masses are attached to this. So one is this one, second, third and fourth. Each has mass equals to 2 kg. So they are attached on the surface of the diameter or surface of the sphere, or you can say at the diameter or the radius starting from this point. So this is a spherical shell. So the moment of inertia of the spherical shell is equals to 2 by 3 m r square. So r is our d over 2, which is equals to 25 centimeter, which is equals to 0.25 meter. Remember that the moment of inertia is with respect to the axis passing through the center of the sphere. Now we have mass on the two masses on the axis and other two masses are at distance r. So moment of inertia of the all four masses equals to due to the first one. So the general formula for moment of inertia is mr square, the general formula. Here the radius from the distance from the axis to the mass is 0. So the moment of inertia of this mass is 0. Similarly, moment of inertia of this mass is also 0. But the distance from this point or the axis and the small mass is r. So we have contribution of due to this mass and this mass. So this becomes mr square plus mr square. So this becomes 2mr square. So total moment of inertia is equals to 2 by 3 m capital R square 2 mr square. This is a very important step here. So you understand that these masses does not contribute to the moment of inertia because the points or the masses are sitting on the axis of rotation. So the distance from the axis of rotation to these masses is 0. So that's why we have 0 moment of inertia due to these masses. All right. Now we have you this formula here. So we need to apply some torque here or the friction torque so as to reduce the angular velocity from 75 revolutions per minute to 50 revolutions per minute in 30 seconds. So therefore, first we will find out the alpha here. So alpha is equals to omega minus omega naught over t or change in omega over time. So change in omega is 25 or you can say 75 minus 50 over 30. So this is revolutions per second square. One revolution is equals to 2 pi angle. And we have here per minute, so we can convert this into 2 pi over 60. So this becomes 75 times 2 pi over 60 radian per second. Similarly, this one 50 times 2 pi over 60 radian per second. So this becomes radian per second square. Or let me write it again. Let me write it again. So we have 2 pi over 60 radian per second square. So doing the calculation using calculator. So alpha is equals to 0.08726 radian per second square. Remember that this is in negative. Negative means that omega is decreasing. We could take the just we took the magnitude here That's why we did not get the minus, but we have to have minus here. It's just saying that this torque is applied to decelerate. So this torque, the torque applied, is to decelerate. You can take care of this negative sign later. It depends on your own understanding how you take care of your minus sign. If you take the plus, it's fine. You say that bracket this torque is actually decelerating, or say minus sign here. So it depends on you. So let's say we put minus sign here. Now we have torque equals to I alpha. So you put the value of the I and alpha. So we have, now first let's, okay, all right. So we first find out I. So this is equal, so we put the mass value small m and capital R. So this comes out to be 0.600 kg meter square. So we put here 0.600 times, minus goes in front of it, so 0.08726 Newton meter. This comes out to be 0.0524 Newton meter. So that must be torque applied so to decelerate from 75 revolutions per minute to 50 revolutions per minute in 30 seconds. So that's your answer for this question. Thank you for watching the video.